So we're going to do affectionately what's known as number 5 or 2.71, where we have these two owners running back and forth or walking towards each other, and the dog running back and forth. Let's see. Start off with my Y, I think. Well, of course I was going to start with my Y. And in my Y, I notice that they're moving at the same speed, but opposite velocities, right? They're moving towards each other, so their velocities are opposite, but their speeds are identical. What does that mean? Where, if they're moving towards each other at the same rate, where are they going to meet? In the middle, because of that, right? So that's something I would put in my Y. Put this down as number 5, which is 2.71, I think. So I'm going to write they will meet in the middle since they have same speed, but opposite velocity. And I'm going to put in there direction 1, direction. So I'm explaining why they're going to meet in the middle, because they have the same speed and they have opposite velocities. I made an assumption there, though. You think they would always meet in the middle? Could we concoct a situation where they wouldn't meet in the middle? If they didn't take the same amount of time, if one started before the other or behind the other, right? So if one had 1 second to walk, the other one had half a second to walk, would they meet in the middle? No. So I kind of assumed, but I should probably show that I really know that. Say something like they have or move for same time. Because that's good to make sure I point out that, hey, I know that. I understand that. Remember, is that better? Okay. What else has that same amount of time to move? The dog. The dog. So I'm gonna note that the dog shares this time. And that actually becomes important, that the dog moves for the same amount of time that they do. All right? So for me, I'm going to draw a little picture just to help myself. I've got the girl standing here. And let's see. Let me just get this right. Where do you want to call where she starts? What location? Like, it's 10 meters between them. Where do you want to put, let's say, 0, our reference point? Okay, we'll put it in the middle. Yeah, my suggestions would either be at him, at the middle, or at her. You could put it anywhere in the world, right? We could put it in Africa, but that may not be helpful in doing the problem. So let's put it in the middle. There we go. So we're going to call that 0 meters. That means she's 5 meters away. And she's moving this way at, how fast? 1.3 meters per second. And she's going to meet in the middle. So as long as the amount of time it takes her to move 5 meters, it's going to take, the dog's going to have that same amount of time to run back and forth. Yes. So, like, let's say it took her an hour. Then he's going to have an hour to run at that 3 meters per second, and he's going to cover some certain amount of distance. I'm not going to worry about, hey, how many laps does he do? That's really complicated. That's like a high-level math problem because they move in continuously and it gets shorter and shorter. You know, it kind of looks like this: long, shorter, shorter. That would get really hard. Well, maybe I'll give that to my calculus-based class. That could be fun. But I know that all of these are going to add up to how far he travels, and that will be that will end up being what we're looking for. So I want to figure out what this time is that everyone shares in common. I want to see if I can do that because I know where she starts, I know where she ends up, I know how she's moving, and I'd like to know how much time it takes her to get from one place to the other. So I'm going to grab my equation sheet, and I've got an equation here that talks about that. It says where I end up is where I started and how far I moved because I was moving during that time, right? It talks about that, those type ideas, starting and ending and moving. So I'm going to grab that. And use that equation. And so, let's see. She's ending up at 0 meters. She's starting at 5 meters. And that's positive, right? Oh, no. Which way do you guys want to say is positive? To the right, this way? Okay, then that's positive 5 meters plus v, that points to the left, so that would be negative 1.3 meters per second, and then delta t. Right? And now I can solve for delta t, because I have number, just one variable. So I pull out my calculator. And let's see, that if I bring the 5 over to the other side, that means it's negative 5. So I get negative 5 divided by negative 1.3. That equals delta t. A little algebra, right? Algebra on a Friday morning. I get 3.846153846 seconds. I don't want to round yet. I want to keep all of those digits because I want to round at the very end so I don't make any mistakes. Hi. No, because the t is multiplied by the 1.3. So I am trying to isolate the t. And to do that, I have to bring the 5 over on the other side. Yeah. So I tend to gloss over the little algebra steps. Oh, that's the side I need to add for our thing. Sorry. I heard a question. The algebra that I did was I need to isolate the t. So what I'm going to do is, and I'm going to write it down here, just I brought the 5 over the other side, which left me with negative 5 meters plus 0 meters on this side. That equals negative, sorry, oops, I put my negative outside. That left me on this side with negative 1.3 meters per second multiplied by delta t. To isolate delta t, I need to divide both sides by delta t. Or to isolate delta t, I need to divide both sides by negative 1.3 meters per second. And that would isolate delta t. No? I found the amount of time that the dog gets to run back and forth. What did they ask me to actually find? How far the dog has traveled. So now we know that how much time the dog was able to run back and forth, and we know the speed the dog ran at. Right. Keep it as is. That's the nice thing about having your calculator back, right? Is you can store it in there. If you're using a phone calculator, just get good at typing in numbers. Yeah. So now let's look at. Sorry, did that algebra make sense? Okay. I know it's getting back in the whole algebra thinking mode. So that was the girl. This is the dog now. I'm going to use the same equation. You know, D equals D naught. So where I end up is where I started and how far I moved. The dog, we're looking at distance now. How far he's traveled, not displacement. That might be good to note over here. Distance for dog. You know, that might have been good to have in my Y. But the dog ends up someplace. We're going to call where he started 0 meters. Because we just care about how far he's traveled. So whenever you care about just how far you start at 0 and go out from there. He moves at 3.0 meters per second. And the amount of time that he moves for is our time answer from up above. And so we end up with a distance of those two numbers multiplied together. Let's see. Oh, nice. It's already there. All I got to hit is times. 3.0. And I get an answer 11.538. So I'm going to round that. I think they want 3 sig figs. That's the standard in this class, so 11.5 meters. Let's see if that's right. See if I got it right. Oops. Oh, we hit in all the characters. Yay! Love it when you get it right on a Friday morning. So I'm actually not going to answer this one because then I would just be giving everyone the answer. But we'll do the Y for it. How about that? We'll think through the Y together, and then you guys can decide on your own how, because this is one that isn't randomized. But we've got this golf cart moves with a velocity of 8 meters per second. It's asking which is it going to go for a further displacement, from 0 to 5 seconds or from 5 to 10 seconds. So some things I would expect to see in your Y for this one, this is number 7, would be that how about the velocity is constant. So not you, let's see, what is it, a cart, right? So the cart moves in the same direction and at the same rate for long time. Never breaks down. What do you notice about those 2 times that they give you? They're both the same amount of time. Remember, whenever we talk about time, we don't care that it's noon. We care that 2 hours has passed. So both intervals are same amount of time. So the cart always moves in the same direction. It always moves at the same rate. And it moves in both cases for the same amount of time. I think that should help you think about how far it moves during each time interval without telling you which answer to play. Believe it or not, there'd be people who would just watch the video and click it without